Hello, hi. This will be our third example on exact first order differential equation. Make sure you watch example 1 where I showed you three possible ways of finding the potential function of the phi. So in this example, A, B, C are all constant. So A, B, C are all numbers. So first we have to check, is this exact? So let's write the way so we can find out the m and the n. So there are many way of doing it. So this negative sign, let me move it on the top or the bottom. Let me move it on the bottom. Okay, it doesn't really matter. So just move that negative on the denominator. Now let's cross multiply. Let's cross multiply. Okay, let's do that. So I get ax plus by times dx equal to minus bx plus cy times dy. And let's move everything to one side. So now you can identify the m and the n. So that's the m and that's the n. Always make sure the sign on the left is included. And if the sign on the left is positive, of course, it doesn't matter. But negative, you have to be extra careful. So let's write it down, the m and n. So my m is ax plus by. And n is bx plus cy. So let's check it. So I have to check, is it true that the partial of m with respect to y is equal to the partial of n with respect to x? Remember, a, b, c are all number. So the partial of m with respect to y, the derivative of ax will be 0 because y is the number. Sorry, y is the constant. So ax, so y is the variable. My apology. So here y is the variable. So ax is like a number. So that's 0. And then the derivative of by is b. So let's check it. Is it true? In here, we're taking partial derivative with respect to x. So x is the variable, y is like a number. So this bx, the derivative is b. Remember, b is the number. And the derivative of cy is 0 because y is like a number. So indeed, they are equal to each other. So this time, let's use way number 3 from example 1. Remember, example 1, I showed you 3 possible way. So this time, actually, let's use the way number 3 to find the phi. So let's do this here. So we know that our phi has to satisfy that the partial derivative of phi with respect to x should be m. So in this case, it is ax plus by. And the partial derivative of phi with respect to y should be n. And in this case, it is bx plus cy. So I'm going to take the integral of both of this equation. That's the way number 3. So the first one, I'm going to take we're going to integrate with respect to y. So we're going to integrate with respect to y. So this will be shorthand for with respect to. And in this side, we're going to integrate, I'm sorry, that should be x. I don't know what happened today. Okay, because you want to go back to the phi, right? So you have the partial derivative with respect to x, you want to go back to the phi. So you're taking you're integrating both sides with respect to x. Here we're going to integrate both sides with respect to y. So let's do that. So here I'm going to get back the original function phi. Remember, you're integrating with respect to x. So x is the variable, y is like a number, and you are doing integral, not derivative. So the if we integrate ax, that's going to be a times the integral of x is x squared over 2 plus by is like a number. So the when you integrate with respect to x, that byx or bxy plus any function of y. Similarly, in this side, when I integrate both sides with respect to y, this will be the original function phi. And here remember, y is the variable, x is like a number. So this bx is a number. So when I integrate bx with respect to y, it's just bxy plus when I integrate cy with respect to y, so that's just c times y squared over 2. So now let's compare them. And remember, any term that appear in both of them, you just take one. So this bxy and bxy appear both of them. So I just take one of them, bxy. In fact, any cross term, that means any term that has both x and y, should appear in both of them. So a term is a cross term that has both x and y in it. So here bxy is an example of a cross term. So that appear in both of them. So I just cross it out and just take one of them. Is there anything that is common to both? No. So everything else, you just write it down. So this one, I have to write it down. And let me write this way, a over 2 x squared, putting all the number in the front of the term. And then plus c over 2 y squared. That's not the answer yet. That's the potential function. The answer is phi equal to c. So the final answer, the solution of this differential equation is going to be phi equal to c. So let's write that down. I should not use c because there is a c there. Perhaps you can use d. Okay, where d is the parameter that d can take any value. So if you choose some a, b, c in the question, right? So if you go back to the original question, if I choose some arbitrary a, b, c here, then I get a question. And the solution of that question is this, where I replace a, b, c by the same number. Wow, fantastic, right? And do not forget, you can do it and believe in yourself. Bye bye.